Hello, Kusto community. My name is Ryan Majitimer. I'm a product manager on the Azure Synapse Analytics team. I'm joined by Brad Watts, who's a program manager on the Azure Data Explorer team. And today we're going to be talking about IoT Data and Azure Data Explorer. In this particular video, we're going to be going over some IoT data ingestion patterns so that you know the most common and widely used methods that people are using today. I'm going to hand it over to Brad. Welcome.
Thanks, Ryan. It's always fun to talk about IoT analytics. We know IoT devices are everywhere today, and the data that they generate is essential for companies everywhere. For many companies, it's really a necessity to be able to get value out of this IoT data. It's no longer a luxury. Azure as a platform provides an ecosystem that meets all your IoT needs, and Azure Data Explorer is a key part of that ecosystem, providing the IoT analytics piece of that. Most of the time when I present on ADX IoT Analytics, I'm really showing the end results. I'm showing how you query the data, how you visualize the data. Today, we're going to take a little bit different approach, and we're going to focus on ingestion patterns, because in order to be able to get the nice, pretty dashboard and to get insights out of the data, the first step is to be able to ingest that. And we see common patterns on ingesting data from IoT devices. In no means what I'll go over today is all encompassing. There's always different ways to ingest the data, but these are definitely common patterns that we see customers utilizing. So just to set the framework, today we will focus on ADX ingestion. We're not going to talk about all the different components of IoT, but focus directly on ingesting IoT data into ADX. We won't cover how the data gets to IoT Hub. We won't cover anything inside of ADX. So once it lands in ADX, we won't cover any of the update policies, the transformations, the queries, the visualizations. Today, we're focusing strictly on ingestion patterns and what that might look like. So let's start with the simplest ingestion pattern, and that's connecting directly to Azure IoT Hub. So Azure Data Explorer has a managed ingestion pipeline where you can connect directly to Azure IoT Hub, and any message that lands on Azure IoT Hub will be ingested directly into a table within ADX. Now, this doesn't allow any transformation, so any transformations that you would do would be within ADX. So the typical pattern here is you land the JSON data that lands into Azure IoT Hub into a raw table in ADX, and then you use an ADX update policy to transform that data and put it into a transform table. So that's really the negative here. The benefit here is it's really easy to get started. It's quick to get the data into ADX. And then you do all of your transformations, your materialized views within ADX. So now let's look at an ingestion pattern where you can do some more advanced transformations. In this situation, what we're doing is we're introducing an Azure function in between Azure IoT Hub and Azure Data Explorer. So in this case, if you're not able to do the transformations with an update policy, then maybe you need to introduce a function to be able to do those transformations. So the Azure function would listen to Azure IoT Hub. As data lands on Azure IoT Hub, it would run your code to do those transformations, and then the results of those transformations using the Data Explorer SDKs would be written to a table within Azure Data Explorer. So the benefits here is you can do more advanced transformations that maybe KQL is not capable of. The negative side is that you need to write the code. So you need to have some development experience, some coding experience to be able to do those transformations, to be able to work with the SDKs for Azure Data Explorer. Our next scenario is using stream analytics. So, with IoT data, a lot of times you'll need real-time insights and use some of the capabilities of stream analytics, whether that's the windowing functionality or some of the outputs that stream analytics has. And so in that situation, what you can do is you can grab the messages from Azure IoT Hub and do whatever you need to in Stream Analytics, and then there's an output from Stream Analytics that will write it to Azure Data Explorer. Now, what's not in this diagram is that a lot of times you're not just writing it to Azure Data Explorer. There may be other components that Stream Analytics is writing it to. Stream Analytics may also be joining it to a reference table and adding context to that data before it lands in ADX. And so those are all situations where Stream Analytics can be useful. And the output makes it extremely easy to connect that stream analytics and write that data into Data Explorer. Now, the negatives here is that you don't always need that streaming capability. So if your scenario with IoT doesn't necessarily need the capabilities of stream analytics, then this doesn't necessarily make sense. There may be situations where you don't need that. You can use the streaming ingestion with ADX, and that gets you close enough to real time to meet your needs. But definitely, if you're going to use stream analytics and there's a use case for it, then this makes a lot of sense to use stream analytics to grab it from IoT Hub and then write it to ADX using the output from stream. So just like stream analytics is a common component when we talk about your IoT data, Azure Digital Twins is also a common component that's introduced. And so we're going to go through two different scenarios in ingesting data when digital twins is a component. And so typically with digital twins, that's representing the model, right? So it's a representation of your IoT infrastructure and your data. And it also typically a lot of times will hold the current value. So you're able to query that twin and get the current value. And so in this case, in this ingestion pattern, what we're doing is this looks the same up to the Azure function, but then instead of writing from the Azure function directly to ADX, we are updating the digital twin. So if a value comes in and it's a new value, we'll write it to that digital twin. Now, Azure Digital Twins has a history component that's built into digital twins that allows you to take that value and write it to a table within ADX. And so in this case, all of our code just writes to digital twin, and then digital twin has the built-in capability to write it to ADX. And so this is a common pattern for ingesting data. And so now you can query digital twins for the model and that representation. You can also get the latest value. And then ADX has a built-in capability with a plugin to be able to query over to digital twins also. So if I needed to go get the context, the model from ADT, and then connect it with the telemetry and the historical telemetry that's in ADX, then I can use that plugin to do that. So the only negative here is that, this is reliant on you utilizing digital twins, not only for the model, but also to hold that latest value. There may be situations in some instances where you're using digital twins just for the model and you're not actually putting telemetry or the latest value in there. And so in that situation, it wouldn't make sense because you wouldn't have the data from digital twins to write to ADX. So that's the only downside here is you would need to be utilizing digital twins, not only for the model, but to hold telemetry data in there. And when I say hold telemetry data, it's always the latest value. It's not a history. It's not an analytical platform. So here's another option. So again, we've got digital twins, but in this case, instead of writing two digital twins and then having the history within digital twins, write it to Azure Data Explorer, what we're going to do is within the Azure function, we're going to, at the same time that we update digital twins, we're also going to write the telemetry data to ADX. And so, this gives you that capability. You can still use digital twins, and maybe you don't have the last value in digital twins, but you have all your telemetry data in ADX. The only downside here is it adds a little bit of code because not only within the code you have to write the digital twins and update it, but you also have to write to ADX, so you have to manage that within the code. Where the previous pattern that we looked at, all the code did was write to digital twins and then use the history capability of digital twins to update ADX telemetry table. So that's the only downside here, but the value is that you have a little bit more flexibility in how you write data to ADX because you're writing it directly from the function. So that was really quick. The most common patterns that we see on ingesting IoT data into ADX. So just as a summary to go through each one of those, the simplest and easiest to get connected is direct connection to IoT Hub. And so in that case, you set up a managed data connection and then you do your transformations via ADX update policies. The next one we looked at was IoT Hub to an Azure function and then write it to ADX. And so what this allows you to do is to do a little bit more advanced transformations within the Azure function and then utilize the SDKs that are available in ADX to write it to ADX. The next one we introduced digital twins. So the last two that we've got on here is digital twins. The first option that we have here is use the Azure Function to update Azure Digital Twins, including the telemetry data for the latest value, and then use the history capabilities of digital twins to write that to a table within ADX. And then the last option is to, within the function, instead of just writing to digital twins, we'll use the SDK for ADT to write it to digital twins. And then at the same time, we'll use the ADX SDK to write the telemetry table, to write to the telemetry table within ADX. So those are 4 really common ingestion patterns. By no means is that all the ingestion patterns for IoT data, but this is definitely the 4 most common ingestion patterns that you see for IoT data landing on IoT Hub and then eventually being inserted into ADX. So hopefully that helps you get a better understanding of your different options for ingesting data and more specifically IoT data into ADX. Thanks.
Well, that wraps up our video for today. Tell us in the comments, what has your experience with IoT data been with Azure Data Explorer? I would love to hear about it. Again, my name is Ryan Majitimer. You can find me on Twitter, but you can also find Azure Data Explorer on Twitter, AZ Data Explorer. Like, comment, subscribe. Thanks for watching, and we'll catch you on the next one.